All right, first things first, if you like my videos, please smash that like button.
Sign up for the STEP program. Yes, the link is below.
Hello, everyone. Today I'm going to go over create a performance task, which is going to be part of your AP Computer Science Principles test. This is one of the most important parts of the test because it really shows that not only can you build an application or build a program, that you can actually explain the program, but more importantly, it also shows that you can follow directions. And that's one of the biggest problems with this test is that you could build an amazing program and still fail or still get a 2 or 1 on this portion of the test because you're not actually providing all the information that the College Board is asking for. So here is a little create performance task instruction sheet. Here on the top, you see computer science principles student handouts. If you click on that, that takes you to this student handout page. Honestly, it's a little bit confusing um, how everything is laid out, but I'm going to try to go through it. This might be a two-part video to try to show you all the components of providing these create performance tasks. Um, One of the things that you have to realize or that you have to take into account is that there can't be any plagiarism. So here is the policy on plagiarism. Um, you know, it's pretty common for programmers and developers to use other code, which in some ways is fine. But for the most part, for this task, they want you to build something yourself. And you can work in a group or individually, but it might be better to work individually if possible, to build out your program itself, and try to do as many of the tasks for the program, writing your own code, not just copy and pasting. That doesn't mean that you can't necessarily look at other code for inspiration, right? So if we go to Snap and you explore Snap programs, here in Snap, you can explore different programs, right? And you can look through these programs like weather reporting system, um, and you can get an idea of how these work, right? Look at their code and see how they code them. But you're not going to want to do exactly the code that they're doing. Um, and you could maybe use some of the same concepts. You could look at some of the algorithms they use and try to code your own or improve your own. But don't directly take any of the code from these because it's actually pretty easy to for them to validate whether you've plagiarized the code. And if you have, you'll get an automatic 0. So be sure to write your own code. But nonetheless, for inspiration, it's not a bad idea to look at some of the codes that are available. Another suggestion I would say is that don't make your program too complicated. Don't focus on creating this amazing program. Really, you want to be able to focus on hitting the points that they want you to accomplish, right? So okay, so I'm not going to go through this. I'm going to go through this create performance task. Basically, you're going to be creating a video, um, or a PDF of the program that you created. A video makes the most sense because then you can show that it's running. Um, and then there's certain things that you have to have, right? These are the basic guidelines that you are required to have, um, in order for it to be functional. So here, let me bring this up, right? So guidelines, plagiarisms. Okay. So these are part of the scoring criteria that they're going to have. So after you make the video, there's going to be a series of questions that you have to answer, and there's a series of things that you actually have to do. So before I go into that, let me show you some examples of these videos. Okay, yeah. So here in the apcentralcollegeboard.org courses AP Computer Science Principles exam page, I'll put the link below. Um, if you so here's the AP Computer Science Principles exam page. If you scroll all the way down, there's actually sample responses that you can look at, right? And so once again, this is like a little bit confusing because you look at this and you're like, I'm not sure how this works. But basically, sample a video, sample a written response. You can look at the video and there's the written response. This is the scoring guideline. So if we looked at that, this is the scoring guideline, which I am going to go over specifically so that you can see what is going to be required. This is the rules or that you have to follow in order to get all the points. I'll get to that in a bit. And then this is the scoring commentary. So this right here shows you how these people scored. So sample A, right? Video and written response. It shows you here. And in this, they score based on the row. Row 1, row 2, row 3, row 4, row 5, row 6. Basically, you could think of these as question 1, 2, 3, 4, 5, 6. But they call them rows. Not sure why, but that's what they do, right? And the total amount of points you can get is 6. One of the tricky things is that if you don't do one aspect, so like if we look at this and you don't do one thing in here, you have to do all the things they ask. If you miss out on one thing, you do not get that point. So it's a zero-sum game. So be sure to hit all the points that they say. So if we look here, right? So we have several examples, and there's only one example that got a score of 6, which is the one I'll go over today, and most of these other ones got below that. Most of these are written in a different programming language than Snap. It doesn't matter what kind of programming language you use. You can use Snap. The idea is that you are able to build a program and explain that program and do the task that they want you to do. The only one that's built in Snap is this Dart game. And I'm going to show the Dart game and the language translator from the example. So here is example 1, right? Or it's sample A. We go to the video. And this right here is a language translator. This is built on the MIT, I think it's the app creator. So wait, hold on. Let me make sure you can hear. Okay. So let me go back to the beginning. So this is MIT app creator. So
noir, rouge, vert, rose, jaune, blanc, orange, blanc, brun, bleu.
Okay, I'm going to pause it for a second. Okay, so as you can see, you click on the French, right? You click on French and then you click on the colors. And when you click on the colors, it says the word in that language in French. So let's continue to look at this. So here, I don't know if you saw that here at the bottom, but it says that you can only select one language if you click.
Azul, marrón, blanco, naranja, amarillo, rosa, verde, rojo, negro.
All right. And you can see there, if you click on Spanish and you click on the buttons, it also says the color in Spanish. You have to only click on Spanish or French. You can't click on both. If you click on both, it gives you a message at the bottom saying that you can't click on both. Let's see where it is. Like down here, select only one language. If you have both of them checked, right? You have both of them checked. So this is created in MIT App Creator. It looks pretty cool. It's actually a pretty good program. So that is that example. And now let's look at the one that's built in Snap. Here it is. So what is your name? So this creates it says you put in a name. It's a mini sports bar. You can pick the different games. Okay, and then you can throw these darts, right? Okay, game over. Okay, so it saves your high score. All right. Okay, and that's it. Let's go back and look at it again. So you know, you come in, you put in your name. You could play darts or pool. You play the game. You create a score. It tells you how many darts you have left. It does game over, and then it saves the score into a list. And that's it. That's the only thing they showed. So those are the two examples, right? So now if we go to the scoring commentaries, right? Here is going to show you what they scored. But before we do that, let's look at the different guidelines. So let me try to make this as large as possible because the text is very small. Okay, I guess that'll have to do. So for row 1, you could have up to 1 point. And the scoring criteria is the video demonstrates the running of a program. And it must include an input, a program functionality, and an output. So you have to be able to put something in, like type in a message or something like that. The program has to function, has to do something. And then there has to be an output that's based on the input. And the written responses for this question need to describe the overall purpose of the program, describe what functionality the program is demonstrating in the video, and describe the input and output of the program or the video. You have to do all of these things. You have to have an input, function, output, and you have to hit all of these written response points. Now, it says, do not award a point, right, if the following is true. The video does not show a demonstration of a program running. Screenshots or storyboards are not acceptable and will not be credited. So you have to have a video and it has to demonstrate the program running. The two videos we saw had a video and they demonstrate the program running. Okay, row 2 or question 2, data abstraction. Once again, you can get 0 or 1 points. These are going to be written responses. It's going to include 2 program code segments. So you're going to have to input 2 program segments. One that shows how the data has been stored in a list or an array. So you have to show how the data is stored. And one that shows the data is the same list being used as part of fulfilling the program's purpose. So the data that you're storing in a list has to be an integral part of the program. You also identify the name of the variables representing the list being used in the response. So you have to create a variable for this list, right? And you have to identify that. Describe what the data contained in the list is represented in the program. So, okay, describe what the data contained in the list. So, like, why do you have this data? And what does it represent in the program? Why is it essential to the program? So, requirements for program code segments. Oh, and by the way, these green sections are like, you must have these. These red sections are like, if you don't do this, you won't get the point. So, requirements for program segments. The written response must include 2 clearly distinguishable program segments, but these segments may be disjointed code segments or 2 parts of contiguous code segments. So they have to have 2 segments. They can be a part of each other, but they have to be definitely 2 segments of the code. If the written response includes more than 2 segments, use the first 2 code segments to determine whether or not the point is earned. So this is for the judges. The judges are going to take the first 2 code segments to evaluate your scoring, and they will not award a point if the use of the list is trivial and does not assist in the fulfillment of the program's purpose. That means if you just have a list, a random list for no reason, right, and it's not integral, it's not an integral part of the input functionality and output of your program, you will not be awarded a point. So don't just put an array in a list for no reason just to fulfill the requirement of having a list. You have to have a reason for that list. Otherwise, you're not going to get that point. Okay, row 3 or question 3 is managing complexity. In your written responses, includes a program code segment that shows a list being used to manage complexity in the program. So you have to show a code segment that shows how you can simplify the complexity of the program, right? Explains how the named selected list manages complexity in the program by explaining why the program code could not be written or how it would be written differently without using a list. Now, we've done this quite a bit, actually, in our previous coding examples, right? We've created these blocks and we use the blocks within other blocks in order to make the code more manageable, right? We had some math blocks recreated, like the greater than or less than, or is it even or is it odd? That's a very good example. If something is even, right? It makes us be able to do other things, like when we're creating the wall, right? We were using the even block as a way to make it less complex. We could do the code without an even block, but by having an even block, it was a lot easier to execute the code, right? So you have to show this. You have to show how you're managing the complexity, and you have to explain what you would be doing otherwise. So this has a big thing in terms of what they will not award, right? If you don't do something. The code segment contains the list are not separately included in the written response section. Not included at all, or the entire program is selected without explicitly identifying the code segments containing the list. So you need to really be talking about the list here, right? So I made that example of even and odd. That's not part of the list. So if you use the even and odd example, which I just used, you're not going to get the point, because this has to talk about the segment that shows the list and how you're managing the complexity of the list. But still, the idea is the same, that you have to manage complexity. Written response does not name the selected list. So once again, we're working with the list. So name the list with this. You're managing complexity. They should call this managing complexity of the list, but they're just calling it managing complexity. The use of the list is irrelevant or not used in the program. Once again, if your list has no reason to be there, it's just a list, that's not going to cut it. You're not going to get the point. The explanation does not apply to the selected list. If you explain something that doesn't have to do with that list, you're not going to get the point. Explanation of how the list manages complexity is implausible, inaccurate, and inconsistent with the program. You need to make sure that when you're talking about the list and you're explaining the list, is that it is accurate, that it has to do with the program, that it makes sense, right? That it actually manages the complexity. It's not just, oh, it kind of manages complexity because it like makes it simpler and easier to use. That's not going to cut it. You need to be very specific about how it manages complexity. The solution without the list is implausible, inaccurate, or inconsistent, right? Same thing. You need to show that there would be a solution without the list, right? That means usually having a lot longer code, and there would be ways to do it, but doing it in a lot longer coding way. But that solution also needs to work, right? The solution without the list must work as well as the solution with the list, because in coding, there's always many ways to do the same thing. The use of the list does not result in a program that is easier to develop, meaning alternatives presented are equally complex or potentially easier. The list itself has to make the program easier and less complex. If it doesn't, you won't get the point. The use of the list does not result in a program that is easier to maintain, meaning that the future changes to the size of the list will cause significant modifications to the code. Okay, once again, the use of the list does not result in the program being easier to maintain. The list itself has to make it easier to maintain. It doesn't matter if there's changes to the size of the list. If the list gets longer, if the list is shorter, it shouldn't make a difference to the way you manage your code, right? That list, no matter what the size, that variable, let's call it like list variable, or I don't know, list, whatever you would want to call it, a list of cats. I don't know, you have some kind of cat game and you need to have different names of a cat. I'm just making stuff up here, but you have cat lists, right? That cat list has to make it easier for you to use or for you to develop this program and to manage the complexity of the program. If it doesn't do that, you're not going to get a point. This part is a little bit complex, managing complexity. So you might want to spend some time in figuring this out. Number 4, row 4, question 4, however you want to call it. Procedural abstraction. Written responses include 2 program code segments, so another 2 program, one showing a student-developed procedure with at least one parameter that has an effect on the functionality of the procedure, one showing where the student-developed procedure is being called. So you have to show 2 segments, and one of the segments has to be something that you developed, right? So it's a function that you developed, right? And one parameter within that function has to affect the whole procedure. So you create a function, right? You create a function, and each function has a parameter, right? So if we have, if we have a function that is, I don't know, say, for example, if we have a function that is counting marbles on a screen, if we go back to our marble video, right? Within that function, right? Within that function, we tell it can count 1 marble at a time, it can count 2 marbles at a time, or it can count 3 marbles at a time. That's a parameter, right? That's a parameter. We are telling the function how to count the marbles. Okay, so if we need to show that we have that parameter and that it affects the function. Now, we also need to show where the student developed procedure, that function that counts marble, is being called, where you're calling it in order to execute the entire program. Describe what the identified procedure does and how it contributes to the overall functionality of the program. So this procedure that you created, in our case, the marble counting, right? You have to show, you have to identify what it does, which is count marbles, and how it contributes to the overall functionality of the program. In my case, in this case, it would be like, we want to be able to count marbles as fast as possible. The functionality is that it counts the marbles, and that's what our program is trying to do, count marbles. And then we have to explain why the parameter affects the functionality as well. So, required for program code segments. The procedure must be student developed, but could be developed collaboratively, can't pronounce the word, I don't know why, with a partner. So you can work on this with another partner. So there's certain stuff, certain parts of the code that you could work with someone else. If multiple procedures are included, use the first procedure to determine whether the point is earned. So if there's multiple procedures that you create, they're going to look at the first procedure. So be sure to talk about the first procedure. Oops. Now, the do not award points. The code segment consisting of the procedure is not included in the responses. So if you show a code and a procedure that's not part of your written responses, you're not going to get the point, obviously. The procedure is built in or existing procedure in the language or structure. Okay, if the procedure is built in, so there's certain things that are already built into Snap, right? We have, let's just run Snap. We have several things that are already built in, right? Like sensing or change X by 10 or whatever these things are, right? Like, yeah, like sensing, like, no, not sensing. Motion is good. Motion is a good idea, right? So change X by 10, change, all of these are already part of the system. You can't just use this and say, hey, I'm explaining how this works. No, you got to build it yourself. You have to make it yourself. Okay. So yeah. So procedure is built in or existing procedures or language structures, such as an event handler or main method, where the student only implements the body of the procedure rather than defining the name, return type if applicable, and parameters. Essentially, what this is saying is that you have to build your own block. Like you have to build your own block and you have to explain how that block works. That's a student developed procedure. The written responses describe what the procedure does independently without relating it to the overall function of the program. So in your response, you can't just say this procedure does whatever, right? You need to be very specific as to what the procedure is doing to the overall program. So for example, here in the drawing brick wall, obviously you can't use this because they'll see it, and several people use Beauty of Joy Computing, but you would be explaining this block editor, right? So this is the row A procedure that you created. Well, you didn't, but if you did, right? And you would explain this whole procedure itself, right? And then this procedure is part of this procedure, right? So this is the complexity. So this right here would be a good example. Draw a brick wall with 10 rows. This is a very good example of managing complexity, except we're not using lists, but it is managing the complexity. And then this is the procedures that's used within another procedure. And of course, we can do this all by writing out the entire code. We're not using a list in this one, so this is not a perfect example, but it sort of gives you an idea of the procedures that you're going to have to explain. And mostly that's going to be within this block editor, right? So you'll probably be helpful for you to also explain that the block editor, right? You're creating these blocks, and these blocks are procedures that you're using within the code. But you'll have to build something that uses a list. So take that into account. Okay, so number 5, algorithm implementation. The written responses include a program code segment of a student-developed algorithm that includes sequencing, right? So sequencing just means a list of different things happening one by one. It's a sequence of events, a sequence of codes. Selection and iteration, right? So you're selecting something, right? Part of that selection is working. So selection specifically means the if statement or the if then statement, right? If this happens, do this. You're selecting this thing to do. If not, do the other. So if we take a look here at our brick wall, and I go to edit, right? We have an if statement here, right? If even, do this code, else do this code. That is selection. Okay, sequence is this sequence of events, you know, step by step. It's doing a sequence of different things, of different events. So that's the sequencing. And then iteration. Iteration is a for loop, or a loop that repeats itself, right? So this right here, here's the repeat function. So we're repeating a certain amount of times. Here it is also, the repeat function, right? That's iteration. You're iterating. You're going over and over again. So you need to have all of those things within your algorithm. An algorithm needs to have a sequence, a series of steps, selection, if-then statement, iteration. It needs to repeat or do something over and over until you tell it to stop. Explains in detail steps how the identified algorithm works in enough detail that someone else could recreate it. So you would have to explain all these steps so that someone else could do it, right? So basically, if I have this procedure that I created, which is even, right? Is the number even? So if the number is even that I inputted here, it will first clear the screen. It will set the cursor to X, a -150, Y 100, and then it will repeat this number, the number that was inputted divided by 2. It will repeat that number of times. So it will do that mathematical equation. So if the number was 4, it will divide by 2. It means it will repeat twice. It will wait 1 second. It will execute the row A procedure, then set X to -150, then change Y by -15. And this is in terms of the cursor. Then it will wait 1 second, and then it will execute the row B procedure that I created, and then set it X to -150 and change Y by -15. What the X and Y is doing is setting back the cursor to the beginning so that it could work, or set it back to the left-hand side, and also bringing it down just a bit so that it can create the next line of code. Row A procedure, right? So then you'll have to explain, okay, the row A procedure, you know, basically draws a brick of the length 30 by 10, pulls the pen up, moves 5 steps, then draws the brick length 30 by 10. And it does that, I believe, 7 times. It does this 7 times. And that's what row A does. And then row B is slightly different in that it has these little shorter blocks. So those are represented here. Draw brick length of 12 with width of 10. You know, pull the pen up, move 5 steps, and then draw 30 by 10 and so forth. So this does this a certain number of times so that it is the same size, right? So you would have to make this explanation complete. And that's, oops. So you have to do all of that. Okay. So requirements for the program. The algorithm being described can utilize existing language functionality or library calls. So the algorithm being described, right, use existing language functionality, so the functionality or library calls. So library calls, what we're doing, right, when we create the row A and row B, or if we do edit, right, if we do this even block, right, we have to explain that this even block is part of a library, right? So we explain that, you know, we have our operators, right? These are different blocks. These blocks are part of our library that we created. One of the library things that we're using is this even block, which also, you know, if we look at it, right, it's actually also a procedure, right? And this is part of a library. This is our mathematical library. We have to use those within this guideline. The algorithm contains selection, iteration, and also contains sequencing. Very important. Has to have all 3. Has to be selection, iteration, and sequencing. An algorithm containing sequencing, selection, and iteration that is not contained in a procedure can earn this point. An algorithm containing sequencing, selection, and iteration that is not. Okay, I think that's just the same. Use the first code segment as well as any included code for procedures called within the first code segment to determine whether the point is earned. So they're just going to look at the first code segment as well as any included code procedures called within the first code segment to determine. So they're going to look at the stuff that you put there in terms of the first code segment and the included code procedure. So you're going to want to be sure that if we're doing this brick wall as our example, right, we're also going to want to show the even. We're going to show the even block, and we're also going to want to show these row A block, right? So you probably want something like this to show, and maybe even the row B. Okay. So you'll want to be able to show all of those. Okay, if the code segment calls other student developer procedures, the procedure called from within the main procedure can be considered even when evaluating whether the elements of sequencing, selection, and iteration are present, as long as the code for the called procedure is included, right? So you have to show all your work, essentially, right? You have to show, even if you're developing certain blocks with other students, like an even block, right? You have to show all the other pieces as well. So they're not going to award a point if the response only describes what the selection algorithm does without explaining how it does it. So if you only explain the algorithm but don't, if you only explain what the algorithm does, right? So if I go here and I say, this algorithm draws bricks along this wall for 10 rows, if you just say that, that's not going to cut it. You need to say how it does it. You have to explain specifically how it does that. The description of the algorithm does not match the included program. So if you're explaining an algorithm that doesn't really have to do with the overall program that you're creating, you're not going to get a point. The code segment consisting of the selected algorithm is not included in the written response. So if you show a segment, right? but your written response has to do with something else. If you're talking about not this block and not this creating this wall, but something else, you're not going to get the point. The algorithm is not explicitly identified. The entire program is selected as an algorithm without explicitly identifying the code segment containing the algorithm. You need to identify the algorithm specifically. In this case, the algorithm we are identifying, right? So the algorithm is the draw brick wall with blank rows. This is the algorithm. This is the algorithm we created. You need to be specific. This is the algorithm we're working with. And then this is what it does. And these are the procedures that it does in order to execute. This is the sequence of events, right? This is the iteration, the if-else statement, right? And the procedures that are within there. And what was the final thing? Selection and iteration. So select, if-else, selection, and then iteration, repeat, right? You have to explain all those pieces. Okay. The use of either the selection or iteration is trivial and does not affect the outcome of the program. You have to have a reason for selection and iteration. There must be a reason to have an if-else statement. If it doesn't have to be there and you're just putting it for no reason, you're not going to get that point, right? So these are the 5 things that you have to do to create your program, right? That's all I'm going to go through for now. In the next videos, I am going to go through the responses. So I'm going to go later on, I'll go through these video samples and the scoring commentaries, and we will see why these people did not get the points that they would have liked to have gotten. All right, till next time. Bye.